can see the board okay. We're okay? All right. All right, guys, this is it. This is the home stretch. This is the last full week of school. It is the last section of notes and quiz that we have to take. I just have a big announcement that I need you guys to be aware of. The routine we've kind of gotten ourselves into these past few months is that we quiz on Fridays. However, this Friday, being that it's our last Friday of school, senior grades are due in guidance by noon on Friday. So I have a few seniors in every single class. So I have those grades that have to be into guidance on noon on Friday. So I can't quiz Friday and then expect those seniors, to get their grades in. So I have to quiz Thursday this week. So our week is going to be a little bit shorter in the sense that we won't be going till Friday. I'm going to go till Thursday and quiz Thursday. So please don't be shocked if you're like, wait a minute, there was a quiz today? Yeah, there's a quiz on Thursday this week, not Friday. All right, and then that gives me Friday to get their senior grades in, and then Monday and Tuesday I'll spend getting all of the underclass grades in. All right, so please remember that, okay? All right, so that means 6.7, this is it. This is the last section. It is solving radical equations. So these are going to be equations with a radical in them. And guys, it's a nice place to stop. We didn't get to we go to chapter 8 normally next. I don't get to go there because just this year being shortened and everything, we didn't get as far as we normally do, which is fine. But this will be our last section, and it's a nice section to end on because it's just going to feel like you're solving equations again. So it's fairly simple in that regard, and that's how we started Algebra 2. We started with solving equations, and now we kind of get to end there as well. So what's going to happen is, since these equations have a radical in them, there's going to be a radical that we need to get rid of in order to solve the equation. Well, guys, just remember how we solve equations in the first place. We use opposite operations. If they're going to add 5, then we're going to have to subtract 5 to solve. If they're going to times by 2, then we're going to have to divide by 2 to solve. So if you have to undo a radical, and a radical is a root, it's taking the root of something, the opposite operation of rooting something is powering it, is raising it to an exponent. So that's how we're going to undo a radical, is by using an exponent or a power. All right? Roots and powers are opposite operations. So we will solve a radical equation by using powers and exponents. So guys, just take a look. Look what roots and powers do to each other. PEMDAS would say to do inside parentheses first. So I would take the square root of 16. It's 4. Now I have to square 4, and I get 16. I'm right back to the number I started with, because at the end of the day, I am squaring a square root. And when you square a square root, they undo each other, and you're just left with the number that was underneath it in the first place. So if you need to make a radical go away, you need to raise it to a power, right? This is the square root of x, but squared. So this square root and that square are going to cancel each other and leave you with just x. That's how you're going to get rid of the radical. This is the third root of x raised to the third power. The third root and the third power cancel each other, and you're just left with x. The fourth root of x to a power of 4, fourth root and a power of 4 cancel, and you're just left with x. So that's what we're going to do in order to get rid of these radicals. We're going to raise both sides of the equation to some power. So it should feel pretty easy, guys. It's really not that bad. All right, so I've given you a list of steps to follow. Now let's look at a couple examples. All right, so if you're going to solve a radical equation, the first thing you have to do is you have to get the radical alone, completely by itself, on one side of the equal sign first. Once you get the radical alone, now you have to get rid of the radical. So you're going to get rid of the radical by raising each side of the equation to the required power. So if you're getting rid of a square root, square both sides. If you're getting rid of a third root, raise both sides to a power of 3. If you're getting rid of a fourth root, raise both sides to a power of 4, and so on. Linda, you all right? All right, so here we go. So right here, I have to solve for x. The x that I am solving for is stuck under this square root. So the first thing you have to do is get the square root alone. So this 6 that's on the outside of the radical needs to go away. So like normal, we minus 6 to both sides. So now I have the square root of x equals 2. Now that the square root is completely alone, I can get rid of it. So if this is a square root, I'm going to have to square it to make it go away. So now we're going to square both sides. And now this square root and that square cancel, and I'm left with x equaling 2 squared is 4. So it should feel like you're just solving an equation. Pretty standard, all right? Just keep using those opposite operations until you have x alone. The biggest mistake I see with this is when students start to square both sides too early. Students will, oh, look, it's a square root, I better square both sides. You are not allowed to square both sides until that square root is alone. All right, so guys, look at the next one. The first thing you need to do is get the radical alone. Well, guys, on this side of the equal sign, it's just the square root of x minus 2. There's nothing on the outside of this radical that needs to go away. In this case, the radical is alone. So we're ready to get rid of the radical. So this is the square root. So let's square both sides to make that radical go away. So this square root and that square cancel. I'm left with x minus 2. And then it equals 5 squared is 25. So in this case, it wasn't just x who was underneath that radical. So when you get rid of the radical, you don't just have x. You still have some solving that you need to do to get x alone now. And all I got to do is add 2. So add 2 to both sides, and you end up with x equaling 27. So hopefully it feels like, oh, this is great. This is not that bad. And it shouldn't be. You are just getting that radical alone, raising both sides to a power, and solving. All right, let's do a few more to make sure we can let this sink in. Okay. This is probably as difficult as they're ever going to get in this section. If you look at this one, right away, I see x, there he is. I have to solve for him. He's stuck underneath this radical. I have to get this radical alone before I can get rid of it. So this 4 and that 10 that are not under the radical, they have to go away. I have to get the radical alone first. So like normal, I'll move the 10 away, the one that's not attached. So minus 10 from both sides. And you're left with 4 times the square root of 3x minus 3. And now that equals 36. Keep going. Get that radical alone. 4 is attached to the outside by multiplication. So how do I undo multiplication? I divide. So divide the 4 away. And then you are left with the square root of 3x minus 3 equaling 9. Now you can say to yourself, okay, I have the radical alone. Now I can get rid of that radical. So since I am square rooting this, that's the root I'm taking, I need to square both sides. So square both sides so the square root and the square can cancel. When they cancel, you're left with 3x minus 3. And now it equals 9 squared is 81. So you're left with yet another teeny tiny equation that you have to solve for x. So let's add our 3 away. I get 3x equals 84, and then divide both sides by 3. And then x will be equal to 28. All right? How do you guys feel? Pretty nice? Pretty simple? We're all right? Okay? All right, just a couple more. Let me show you some other roots, and then we'll go from there. So in example 4, here is a third root radical. All right, same thing though, don't jump the gun. The first thing we gotta do is get this radical alone. So the 2 and the 4, they can't be here. So let's minus the 4, the one that's not attached, away. 2 times the third root of x equals negative 4. Divide both sides by 2, and the radical will finally be alone. All right, now let's pause for a second. You have the root of something equaling a negative number. The fact that this is a third root is perfectly fine. We know you can take the third root of a number and its answer be negative because something times itself 3 times could end up negative. If this was a square root and it said the square root of x equaled negative 2, is the square root of a number ever supposed to end negative? No, not if it's a real number, right? So it's okay that this equals a negative number because it's an odd root, not an even root, all right? So now how am I going to undo a third root? I'm going to raise it to a power of 3. So now we have to raise both sides to a power of 3, and then they will cancel, And I will have x equal negative 2 to the third power, guys, is negative 2 times negative 2 times negative 2. That's negative 8. And you're good to go. All right? All right, now we have a fifth root radical. If I'm going to get rid of a fifth root radical, I'm going to have to raise both sides to a power of 5. But not yet. Get that radical alone first. It's quite simple to do that. All I have to do is minus 5. So let's minus the 5 away. And I'm left with the fifth root of 4x equaling 2. Well, what's going to undo a fifth root radical? A power of 5. So let's raise both sides to a power of 5. They will cancel. I'm left with 4x's equaling 2 times itself 5 times, guys, is 32. And then the only thing you have left to do to get x by itself is divide both sides by 4. And then you get x equals 8. All right? So again, hopefully you're like, all right, I can do this. This is not going to be that bad. All right, I'm going to ask you guys to do the last one on your own, and then we'll see what you get, and then that's that. I will tell you guys, though, if you get a decimal or a fraction for the last one, you're not wrong. It is a fraction. It is a decimal. What's up? Oh, sorry, Kyle. I thought your hand was free. That's how I would have started it. Minus that 7 out of there. Divide by negative 2. And again, the fact that you have the third root, the odd root of something equaling a negative number is perfectly fine. That can happen. Raise both sides to a power of 3 to get rid of that third root radical. You're going to be left with 2x plus 5 equals negative 4 times itself 3 times is negative 64. And then you're just left with a basic equation. Let's minus the 5. 2x equals negative 69, and then divide both sides by 2. So x will either equal negative 69 halves if you leave it as the reduced improper fraction, or the decimal is not that bad. It's negative 34.5, and you're done. All right? Everybody feel okay? It's not that bad, right? It's kind of like a nice section to end on right now. All right, at home, can I get a thumbs up? You guys are okay? All right, so guys, tomorrow I'll have one other version of these equations to show you, and then that's it. Then we'll have Wednesday to kind of like wrap it up and prepare, and then Thursday will be our quiz. And then, guys, you can stop listening to me, all right, if you haven't already. So otherwise, I did make a homework tonight on Delta Math that is due tomorrow night at 11:45. It's 8 questions on solving these radical equations. Please let me know if you need help or you have any questions. Otherwise, I'm pretty sure, let me just double check the attendance one more time. You guys are going to be good to go at home.